Okay, so what's next? Well, for us, the next step would be to start creating the actual schedule of the project. We now have done so far the process of creating the work breakdown structure, then creating the list of activities based on the work breakdown structure, and then we were now able to sequence the activities to determine what comes first or which activities are predecessors of other activities. Um, at this point, what we need to do now is to estimate how long each activity takes in order to finally do the project schedule. But how do we estimate is the question. That is the focus of this podcast. And if you don't mind, for the rest of the slides, I will not show a video or my face. This will just be a podcast. With that, let's start.
So, like I said a little while ago, really the next step after the creation of the work breakdown structure is to put estimates. But when we do have to make estimates, we have to distinguish between two types of activities and the relationship of these activities. We have to be able to distinguish the effort of an activity and the duration of an activity. Now, whenever we talk about effort, effort reflects the amount of personable or billable time an individual is planning to devote to task completion. Now, take note, it is the plan of an individual. It's coming from the individual himself, and with the individual, they themselves are going to be able to tell you whether they're going to give you 100% of their time or just 50% of their time. The definition so far of effort here is that they are going to take 8 hours a day. So whenever a person will actually commit and say, I am going to give 100% of my effort, they are going to say 100% of the whole working day. In other words, 8 hours. If they say 50% effort, then that means 4 hours a day. Now, effort is totally different from duration. Duration really reflects the elapsed time between a task's start and finish. Well, a duration can be the same as effort. When can duration be the same as effort? If the effort is 100%. So, if the effort is 100%, the duration, if it takes 4 days and a person saying that he will take 100% or give 100% of his time, then really that 4 days is the whole duration of the project. Now, if the person says, I will just give myself 50% effort, then that 4 days doubles. You can say that now will take 8 days, assuming that the ratio is proportional. So, effort comes from the individual, the amount of time that he's willing to spend. Duration really is time. One thing also about duration is that there are two categories of duration. A duration for an activity can be fixed, and whenever an activity it has a fixed duration, it means that no matter how many people you put there, the duration of the activity does not change. So examples here would be deliver. You don't need 500 people to deliver one document. The time it takes you to deliver that one document is the same whether or not you have 500 people or just one person. The other type of duration or category of duration is what you call variable duration. And when you talk about variable duration, in this case, the more people you assign to the task, the quicker the task will finish. Example here would really be painting. So painting a room. If you have one person, that one person might be able to finish painting a room in 4 days. But if you add four people, maybe the duration becomes 1 day, primarily because the activity is a variable activity. From an IT perspective, examples of fixed time would be delivery of servers would be one of them. For variable duration, maybe programming would be an example in variable duration. Of course, one thing you learn from your software engineering or system analysis design is that too many people sometimes spoil the soup, or too many chefs sometimes spoil the soup.
So, after learning about those two terminologies, let me now give you 5 ways that we can estimate the duration of a project. The first one will be top-down estimation. The second one will be bottom-up estimation. The third one will be standard cost and time. The fourth one is what we call historical relationships. And the last one will be Simpson's rule.
Um, First one is top-down estimation, and as the name implies, you try to identify large blocks of effort from the work breakdown structure. You start off with phases, and the idea here is if you have a phase, you have an idea of thinking this particular phase will take me X number of months. So, as an example, let's try the software development life cycle. Let us say that you're given 10 months to finish a project. What you can do is just break up that 10 months and allocate a certain number of months per phase. So um, for the system analysis and design, that might take you 3 months. Next one would be the programming, that would take you 2 months, and then the implementation might take you just 1 month, and then the last one might be maintenance. So what you're doing is from a very high level perspective, you've already allocated certain chunks of time to the different phases of your project. The advantage of top-down estimation is that it's quick. The main advantage really is that it's really inaccurate. But why do people use top-down estimations, and who use top-down estimations? Well, top-down estimations are done by people who have had previous experiences or a lot of experiences with a certain type of project that they are going to be executing. So, for example, maybe perhaps Rai here can give a good estimate of how long it will take to plan for a particular event in MISA, primarily because he has been part and parcel of a lot of projects in MISA. And he will tell you that creating a seminar, mainly, for example, Potis Immensity, would take you 3 months. And out of that 3 months, 1 month is going to be set for thinking of the theme. Another month would be trying to lay out the groundwork, and the third month will be really for all of the details that are needed, mainly reservation of rooms and so on and so forth. Okay, so if you have had previous experience about a particular task or activity, or even a project, then you can do top-down estimation. Now, the opposite of top-down estimation.
So what you have here in this slide is a visual representation of how a top-down estimation strategy works. You start off with a given chunk of time, that is the project will take 12 months, and then from your own personal experience, you're going to break down those 12 months into smaller and smaller time chunks. And you distribute those time chunks according to the components of your work breakdown structure, and eventually to each and every one of the activities. So in this case, I started out with 12 months. I have two major components. The first component will take 10 months, the second component will take 2 months, and so on and so forth. So at the end of the day, what I'm essentially saying is that I have uh, five, is it five? Yeah, no, six major time chunks. The first one will take me 3 months, that's subcomponent one. The second one will take me 2 months, that's part one. The third one will take another 2 months, that's part two. The fourth one will take me 1 month, that's part three. The fifth one will take me 2 months, and that is subcomponent three. And the last one, the sixth one, will take me another 2 months, and that is component two. Something similar to the top-down estimation is what we call analogous estimation. Um, in analogous estimation, a project manager uses one or more similar projects in the past to estimate the duration of or the cost of your current project. So let's take, for example, your MISA projects. You know from before that you constantly be doing your hackathons, for example, and you know that a hackathon before takes you 10 months to prepare. So you're going to use that same 10 months as a basis for the schedule of the current hackathon that you'll be doing this year. So that's what you call analogous estimation.
Is what you call bottom-up estimation. And in this case, what you're going to end up doing is looking at each and every activity and then asking the people how long each activity will take. And for every activity, you start adding it up until the highest level of phase. So imagine again your work breakdown structure. Go to the granular activities. Try to identify how long each and every one of those activities take, and then add them up. Continuously start adding them up, going up and up and up until you already have the total of the whole project. Now, the strength here really is you have greater confidence in small increment estimation because you are really looking at each and every activity and you're going to the lowest level of detail. Unfortunately, the main weakness here is that it is time consuming. Imagine going through 300 of those activities and asking each and every responsible individual how long it will take. The other problem here is that it is prone to what we call padding. Dadayain noong person, sasabihin, I think I know that I can do this in 5 days, this particular activity in 5 days, but since I don't know what exactly will happen, sige, dadagdagan ko na lang ng konti. So, imbes na sabihin ko 5 days, I will just tell my project manager 8 days. Now, that difference of 3 days might not matter, but what if everyone does that? You're now going to end up with a project that is bloated in terms of duration, in terms of the estimates. Imagine if each and every individual just adds 3 days, or maybe worst case, 1 day, and you have 100 activities. Now, just adding 1 day to each and every one of those activities will yield you more or less around 5 working months, an additional 5 working months. Okay, so it's no wonder that sometimes top management does not believe the project manager when a project manager gives them an estimate. Okay, so two different types of estimation: top down from bottom up, phase down to the activity. Bottom up is from each and every activity up to the phases. Each and every one of them has their own pros and cons.
Okay, so this slide is a visual representation of how bottom-up estimation works. The idea here, like I said in the previous slide, is you directly ask the people who will be responsible for doing that activity or work package and ask them directly how long it will take. So in this case, subcomponent 1, after asking the person responsible, will take 4 months. Part 1, after asking the person responsible, will take 3 months, and so on and so forth. And what you're now going to do is, once you have all of those lowest level time chunks, you start aggregating them until you now get the total duration of the whole project. Something similar to a bottom-up estimation is what we call parametric estimation. And essentially, a parametric estimate is determined by identifying the unit cost or duration and the number of units required for the project or activity. So in this case, if it took me 2 hours to mow my 1 acre yard last week, and this week I'm mowing 4 acres, I could estimate that it will take 8 hours to mow that 4 acre yard. Okay, so that's, in a sense, it's like a bottom-up estimation because you go directly to the person responsible and asking them, how long did you take to do a similar activity in the past?
So, if we cannot do level of effort, because level of effort depends on the availability of people, let's now look at very standard ways of trying to determine time and cost. Well, we can use standard costs and time. Now, this is simple. I think for some of you, if I ask you, how long would you think it will take you to create a web? What you are going to end up doing, or a website, sorry, what you might end up doing is really going to the web and try figuring out what is the industry standard. Okay, so industry will say, okay, if you have a web and it's this particular configuration, by default, it will take you X number of days. This can be done because there's a lot of people who have done it previously. And if a lot of people have done it previously, then more or less, given the same specification, more or less, you should take the same amount of time. Also, there's a lot of assumption there. That you have the same skill set as they have, and you know the same platform as they have, and so on and so forth. So for this type of scenario, if it is a known repeatable activity and it's a standard operation, you can use standard costs and time. Now, the strength here is that the accuracy really is increased because you have previous historical data to back you up. The weakness, though, is that, at least in the Philippines, there's very little historical record to back you up. Okay? The other weakness is that it also assumes that everything is standard. And again, if you look at it from a website perspective, the standardization there should have the standard set of skills that the people who said that to create a website of a certain configuration, it will take 10 days. Maybe for you, it might not take 10 days because you don't have the same level of skill set as they have, especially if you are just starting out in creating your own website that is maybe in PHP, using CSS, and so on and so forth. Okay? So, although standard costs and time are very useful, I would suggest that this is just simply for you a starting point because definitely each and every one of you will have different skill sets and maybe are not at par with the standard. Ideally, we want to match up with the standard. Okay? But let's face it, not everyone has the same skill set. The other something related to standard cost and time is what you call historical relationships. And this basically means that there are really stable ratios that could exist already, that has been done through research, and that has been used by everyone. Think of it as something like rules of thumb. Okay? So one example is that if you want to make a house, usually um, if you go to an architect, the architect and contractor would tell you that, okay, if you want to build a house, how many square meters do you have? And out of that square meters of your lot, how many of that lot will be for the house? Now, if you have an idea that you have a 150 square meter lot, and out of that 150 square meter lot, you're just going to make a house in 100 square meters there, the contractor will tell you, okay, for every square meter, it will cost you, if you're going to create a two-story building, for every square meter, that will already cost you 100,000 pesos. And that 100,000 already is all inclusive from the plumbing, the materials that you're going to need, the paint, the electrical, automatic. Okay? And that's from an architect's point of view, what we call a rule of thumb. Okay, in IT there are some of them, like some stable ratios exist in terms of documentation, and for example, it could be that for every page of code, it usually takes a developer 3 hours to debug. Okay? Or a tester 3 hours to test for quality assurance. That may be a historical relationship. Okay? Another way of looking at it is for every 2 days of programming, it's equivalent. You will have to allocate 3 days of testing. Again, that's another standard, another rule of thumb based on historical data. Okay? Now, again, you're lucky if you have historical data. If you don't, then you're unlucky. This you can only get from the internet, and most historical relationships are usually on at the phase level. So historical relationships will give you a very quick and dirty estimate of how long the whole project will take. Okay?
The last strategy for estimation is called Simpson's rule for estimation, or also called the three-point estimate. Now, for this strategy, it tries to lessen the anxiety of estimating, primarily because instead of just asking one person as to how long it will take him or her to finish the task, you ask three people. And that's the reason why you call it the three-point estimate. But the choice of those three people is a little bit deliberate. You choose one who is the average in terms, or who can do the activity in an average amount of time. You choose a second person who can do that activity as quickly as he can. And the third one is choosing someone who you think does the activity in the slowest amount of time. The idea here is that because you get a range of time estimates and then you average them, you will get a sense of roughly how long that task would take to finish on the average. And you're not going to just be dependent on one person's estimate. So let's give an example to this one. Um, Supposing you have as part of your work breakdown structure a module that needs to be programmed. So instead of just relying on one programmer who might be the best programmer and saying, okay, how long will it take you to program this one? He said, oh, that will take me 5 days. And eventually later on, you're not going to get him. You're going to get a slow person. Your duration will already be off. Actually, your whole schedule will be off because your 5 day estimate is based on a person who is good, but right now is not participating as part of your project. So, um, just to illustrate how it works, for the module that you want to be programmed, you look for 3 people and you get the best programmer, a bad programmer, and an average programmer. And you ask each one how long it would take them to program that specific module. So let's say the best programmer will take 3 days, the bad programmer will take 20 days, and the average programmer will take 6 days. Okay, the best is what you call the minimum. Okay, the bad is what you call the maximum or the pessimistic. The minimum, by the way, is the optimistic, and the average is what you call the nominal. So how does this help us? Once we have the values, what we will do is plug the minimum, the maximum, and the nominal into Simpson's formula. So this formula was derived after looking through a lot of data with regards to estimation. So what Simpson's formula says is that to get the average of your estimate, you add the minimum, the maximum, and 4 times the nominal, and then divide everything by 6. Now, first question, sir, where did we get the 4 and the 6? This is for the 4, that's based on the research, and 6 because you have 6 points to average. You have 1 point for one data point for the minimum, 1 data point for the maximum, and 4 data points for the nominal. So all in all, you have 6 data points. So that's why you divide everything by 6. Applying the formula to the problem that we had, this is how it will be used. So you have your Simpson's rule. 3 is the minimum, 6 is the nominal, 20 is the maximum. Plug it in the formula and you get this value. 3 plus 4 times 6 plus 20 over 6. And that will give you 7.83 days, or we usually take a round up perspective. That particular module will be finished by in 8 days. Okay, so that's how you use Simpson's rule. Okay, I think that's it. So what I've shown you are 5 different strategies in estimating the duration of not only the project, but it can also be looked at as the duration for each and every component of your work breakdown structure. So if you look at each and every one of the components of the work breakdown structure, or each and every one of the activities in your activity list, you can now say, oh, I can now estimate this work package in this way, and I can estimate this activity in this manner. Please take note though that ideally it would be good to use the same strategy across all of the work packages and all of the activities. That is, if you're planning to use standard cost and time, use it across. But sometimes there are situations when you can't use one strategy across all of them. So you can use a mix. Best practice though is to just use one strategy. Okay, I'm back again. So this ends our discussion on the section on estimation of the duration of the activities. Um, in the next 2 pages, 1 or 2 pages, you're going to have further readings just to clarify these strategies and a short activity just to make sure that you understand how to use each and every one of these strategies. So with that, I'll see you in the next podcast or video that I will make. Bye.